Welcome to the Power of 10. We're glad you joined us. Before we begin, let's go over the features of the platform you're using today. On the left side is the video window. On the right of the screen, you will see two tabs, Chat and Q&A. We encourage you to be an active member in today's discussion. Use the chat window to say hello to the panel and fellow attendees. Use the Q&A window to submit your questions for the panel. If you have an interest in a question already entered, click the Upvote button. That will make the question rise in priority. Now that we've gone over the platform features, let's begin.
We choose the challenging path, ever forward. It begins with hard work and humility, and the courage to fail.
Let's go!
Strengthened by our community, we make each other better. There are no shortcuts on a lifelong journey. At Vanderbilt, we dare to grow.
Hello, welcome to the Power of 10 Forum Series. I'm Robbie Hayes, Chairman of the Board of Directors of Cumberland Region Tomorrow, a nonprofit organization that works to improve the quality of life in our 10-county region. We are excited to engage with you and address some of the most important issues facing our region. We are thankful to the panelists who share their time and expertise with us and you during these discussions. And we are very grateful for our sponsors and all of our supporters who make this series possible. We hope you engage in these discussions and work with us to make our region an even better place to call home. Good afternoon, everyone. Hello and welcome. Again, my name is Robbie Hayes. You are at the Power of 10 Forum Series hosted by Cumberland Region Tomorrow. I serve as our board chair. I also work for H&TB, a transportation infrastructure consulting firm with an office here in Nashville. I'm going to be your facilitator today. This is a topic that is near and dear to my heart, and I am really excited about the opportunity to introduce our speakers today, and let's talk a little bit around congestion management and technology solutions and how that's going to help this region. For more than 5 years, TDOT, Vanderbilt University, Gresham Smith, and others have been working on the I24 Mobility Technology Interstate Observation Network, or MOTION. This 4-mile test bed is helping us learn about our region's commute. It is improving mobility, and it provides us with an opportunity for future research. Today, we're going to learn a little bit more about that. Before we begin, though, I'd first like to thank Vanderbilt University for their generous sponsorship for this forum. Without the support of Vanderbilt, we would not be having this discussion today. And of course, thank you to all of CRT supporters. We've got a great panel. I'm excited to jump into this. Let's start with some introductions. First off, we've had Matt D'Angelo with Gresham Smith. We also have Lee Smith with Tennessee Department of Transportation. And then we also have Dan Work with Vanderbilt University. I want to go ahead and allow them to provide a brief intro on themselves and a bit of a bio. So Matt, why don't we kick it over to you if you want to just give us a little bit more about your background.
Thanks, Robbie. Appreciate this opportunity to share more about the I24 Motion project. As Robbie said, I'm with Gresham Smith, and I lead our TSM&O practice for the firm. And so what that means is we look for opportunities to leverage technology and operation solutions to help manage the infrastructure, the transportation infrastructure that we have. And in that role, for the last 25 years, I've been very fortunate to be able to work with TDOT and many other agencies who are exploring how to apply technology and mobility solutions so that we can move the needle on safety, as well as provide greater transportation mobility across the regions and communities that we serve.
Thanks so much, Matt. Next up, we'll have Lee Smith.
Thanks, Robbie. My name is Lee Smith. I'm with Tennessee DOT. I have been with TDOT. Now I'm the Assistant Director of Traffic Operations and Technical Advisor for Traffic Operations Division in TDOT. Been with TDOT for about 5 years. Traffic Operations Division at TDOT manages all of our freeway management, projects, as well as our ITS and Intelligent Transportation System deployments, and just really try to work with our partners on improving safety and mobility. Before coming to TDOT, I worked for Florida DOT. And then also before that, I was a city traffic engineer down in Florida. I've been in the industry for about 25 years, sort of similar to Matt, and really excited to be here and have this conversation.
Thanks so much, Lee. All right, Dan, I'm going to turn it over to you.
Hey, Robbie. Dan Work here. I'm a professor at Vanderbilt University in the Department of Civil and Environmental Engineering, and also the Institute for Software Integrated Systems. I probably still hold the record as being the only person who ever moved to Nashville because of the traffic, but it's true. Our research group focuses a lot on how we can use new technologies. 15 years ago, it was a cell phone that had a GPS sensor on it. Today, it's new cars that have advanced sensing and control capabilities, like a smarter cruise control, and really thinking about how those technologies are going to shape the future of transportation. So glad to be here.
Great, thanks. And again, thank you all for being here. Look forward to today's dialogue. Our membership and folks that participate in Cumberland Region Tomorrow, have a very diverse background: community leaders, public and appointed officials, planning practitioners, engineers, just folks that have an interest in the quality of life for Middle Tennessee. And, I think today's topic is very relevant to the challenges we face in Middle Tennessee. So, but before we sort of dive into the details, maybe let's just kind of keep this high level to bring others up to speed. Lee, this first question's for you, but feel free to jump in at any point, Matt and Dan. Just for the audience, maybe describe a little bit more about what is a smart corridor, and what are the technologies being applied on the I-24 corridor?
Sure, Robbie. So a smart corridor is the application of technology to try to resolve traffic congestion and safety issues. In the case, so basically, there's a concept called TSMO, Transportation Systems Management and Operations, and it's really trying to manage the capacity and manage the existing system more efficiently, and smart corridors are part of that. The I-24 smart corridor, kind of the home of the I-24 motion project, and the is really a conglomeration or a confluence of technologies and strategies. It kind of operates under the concept of ICM, which is integrated corridor management, which where you really look at the freeway and the arterial roadway holistically. You manage them together. Because a lot of times the freeway is managed by the DOT, the arterial might be managed by a local agency, and the two could have similar goals, but not be able to work together. So this project serves to establish that partnership, and then apply technology to that. And really in the case of I-24, the existing freeway system, we have cameras, sensors, overhead message boards. We're taking that to the next level with things like lane control systems, variable speed limits, and then the complementary arterial, using technology to manage that traffic signal system more effectively with fiber optic communication, advanced detection, and then eventually, in this case, cameras and message boards. The whole goal is to affect safety, the number and the severity of crashes, and then affect travel time reliability, not to get you there necessarily faster, but to get you there the same amount of time each trip. So you can count on planning your day around the trip between your home and work, your home and school, to be a similar travel time each time. So those are the kind of the high level goals of a smart corridor. It's a matter of trying to really apply technology instead of widening a road, which we have very little room to do that, and the funding and the time it takes to do that. We're trying to manage the capacity we have to squeeze every bit of capacity we can out of the existing pavement out there.
Yeah, that makes a lot of sense, and I appreciate that that sort of background. I guess maybe kind of keeping it an open-ended question, more generic in scope, but why I-24? What was the decision that went into this? And why did TDOT decide that this is something that they want to take on in this particular location?
Yeah, that's a great question, Robbie. And it goes before my time, but the people that looked ahead and were kind of visionary in what could be done. But you're looking at the entire state of Tennessee, this stretch of I-24 between Murfreesboro and Nashville is the most congested corridor in the state. We've got anywhere from 150 to 200,000 cars per day out there. We have anywhere from 1,000 to 2,000 crashes per day or per year out there per day. Crashes per year out there. And so it was the worst problem to tackle. And from a kind of a academic sense, I'm not to say that with Dr. Work in the room, but I almost would have liked to try it on a less congested corridor to kind of get the strategies down and try to, but we've chosen, I think, very, appropriately to tackle the worst corridor in the state because it's where the worst problem is. It's where we want to affect safety and we want to reduce the number of crashes and the severity of crashes. So where else would we go? We'd go to the worst case, the worst problem we have to try to tackle that.
Yeah, and obviously there's a clear felt need for anyone that's driven, throughout the region. At some point, you spent some time on I-24, maybe not moving as quickly as you would like to be, especially for those folks commuting in and out of Nashville. So thanks for that, Lee. Matt, I'll kind of throw this one your way. How's the I-24 Smart Corridor improving safety and mobility? I know that we're collecting a lot of data, and data is very important to help us inform future decisions and things like that. But maybe if you could just dive into a little bit more detail on, how is this working?
Yeah, sure thing, Robbie. So I think first is taking a step back as I think about the types of technologies we've had as tools in our toolkit, our operational toolkit. We started out with this understanding of how can we improve our situational awareness? How can we determine that there's an issue that is impacting traffic and potentially the safety of the system? And so the earlier generations of these types of projects were very much focused on equipping traffic management centers with the type of video information and data and messaging capability to be able to what we refer to as incident management, which is being able to remove any obstructions to the travel way. Where Smart Corridor kind of takes it up a notch is this is an active traffic management approach. And by active, it means we're actually taking measures to influence traffic, to actually influence the decisions that drivers are making in a more proactive way, which is why if you drive through the I-24 corridor, you will experience in this section of about 30 miles these lane control signals and variable speed limits that are posting advisory messages to drivers, but they're very intentionally crafted messages that are intended to create an active compliance with those messages that will benefit everyone, that will benefit the entire traffic stream. And so this system was activated just recently this summer in June. And so the data is currently being analyzed and continuously analyzed for performance measures of how we are moving the needle. What we have understood so far and been able to observe is a benefit to safety, quite an interesting benefit to safety along the corridor in terms of reduced crashes. Because anytime there's a crash in the system, not only does that interrupt the available capacity to move vehicles through the system, it also creates an additional safety hazard. And one of the issues that we're always challenged with are what are known as secondary incidents or crashes. And so if we can reduce fundamentally the number of crashes that are occurring through a smart corridor, active corridor management approach, then that already gets us ahead of the game in reducing the types of the impacts to the traveling public. And so we've seen an early calculated benefit to safety, and we're also seeing some impacts to travel delay. which is also a very promising finding. And so as the smart corridor data continues to come in and be analyzed, we'll have more information about specifics in terms of the benefit. But what we've seen so far, Robbie, has been very promising.
That's great, and I appreciate that explanation, Matt. It certainly is exciting to think about this as more than just, traffic flow or travel time. It's really about safety, which I think is something near and dear to everyone, right? We'd love to have safer facilities out there for the traveling public, for businesses. It also benefits, agencies, getting to healthcare, schools, jobs, everything, and being able to do that in a safe manner, particularly on a corridor that has a lot of congestion, some of which may be driven and likely is driven due to safety issues. And so kind of taking that safety first approach, I think is certainly interesting. So we introduced an acronym earlier, motion. Dan, I'd like to just maybe see if you could break that down for some of us, that aren't as, skilled in this particular area. What is motion, and kind of what have you learned so far through this opportunity?
Yeah, I24 Motion is basically a set of 294 video cameras that are processed to create anonymous traffic data. And that traffic data really helps us understand the health of the freeway. The way that I think about it is that, across the country, we have sensors all over our freeways. And those sensors are effectively X-rays. If you've got a crash, if you've got a broken bone, they tell you what's going wrong, right? But a lot of times you may have something wrong with your leg or your ankle, which is not showing up on an X-ray. In traffic flow, that basically are these things called phantom traffic jams that are created by human drivers. The way that you and I drive creates a certain dynamic in the traffic that creates these stop and go patterns. And there's basically been no good way to measure this stuff. If you can't measure it, it becomes very difficult to design engineering solutions to make it better. So I24 Motion really started with that idea that, like, if we are really going to better improve mobility and safety on that freeway, we need to improve our ability to measure what's going on. And so Motion really provides a best in the world capability to really appreciate how traffic is flowing, so we can catch beyond the crashes that obviously cause traffic jams and get to the heart of other types of suffering that happens on the freeway. Everybody that drives on that roadway, or really any major congested roadway in the world, knows you speed up and slow down for no apparent reason, then you speed up again. Those jams are caused by the dynamics of the way that you and I drive. And one of our big pushes has been thinking about, well, what if we either tried to change the way that everybody on Earth drives? Come see me when you want a driver training program. I think exactly 0 people are interested in that direction, because I'm a good driver. It's just everybody else it's not. Right? Or if we were able to use technologies that were already coming on cars that you and I can buy today, and those things just help make traffic better overall, wouldn't that be nice? And so a lot of the research we've been thinking about is exactly that: how to take new vehicular technologies to help reduce some of the types of suffering on the freeway that you and me, when we're driving on our own, help produce on that roadway.
Awesome. Thank you for that. And we did have a comment in the chat. Maybe I'll ask Lee if you're comfortable with answering this, or we can just open it up to the panel itself. What is the clear distinction between the I24 Smart Corridor and Motion? Because I think there might be a little bit confusion. I mean, there certainly is, when I was trying to get brought up to speed on this, and, again, not having that technology background. And I know, there's probably some overlap and things there, but maybe let's take a moment to, provide a clear distinction between the two, if that's possible.
Yeah, I think that's we can do that. They're intrinsically connected. TDOT, strategically selected this stretch of I-24 to place I-24 Motion as a research instrument, like Dan had described, that can serve, multiple purposes. First of all, it can serve TDOT, I guess selfishly or what have you, to enhance, to optimize the strategies we've deployed on the smart corridor. So theoretically, you could place Motion anywhere. but
Yeah.
we thought that the best place for motion was a smart corridor because it has such a robust set of technology already deployed that we could leverage and be able to complement one another, just from the perspective of making the smart corridor operate as optimally as possible. But then motion has a whole myriad of other uses and other test cases. Basically, like Dan was describing, any stimulus you put in that traffic flow on I-24, which we know has unique driving behavior, we can see that with a fidelity we haven't been able to see before, that MRI for traffic, because that's on a vehicle by vehicle trajectory basis. So it serves I-24 Smart Corridor first, and then it serves the rest of the other states that want to look at their strategies, automotive industry, device manufacturers, and on. Any stimulus that you want to put in that traffic flow. So that's how they connect. They really are intrinsically and linked between the two. That's in my opinion, and maybe Dan or Matt could add to that. That's how I would describe this distinction.
Dan or Matt, anything else to add to that? I thought that was a good explanation, Lee. Thank you. Okay. I mean, with so much going on here, and it's such a cool sort of conglomeration of, the DOT, university, private sector. Lee, you kind of mentioned too how this can help inform, decision making or product development for the automotive sector. Or maybe let's talk a little bit of sort of about that collaboration amongst all these different groups coming together around one project, one research, data points, things like that. I mean, has this helped facilitate those relationship building and conversations and maybe ultimately decision making? How is that all working, as a result of these two products?
That for me, Robbie?
That's kind of an open-ended one. Lee, why don't you take that first and then we'll pass it on.
I'll try to be brief. I can be long-winded. So I just wanted to make one point, I guess, and let my colleagues add. Actually, Matt had said this before, but compared to other research projects, it's I think a unique partnership, but also applies and can further other research partnerships. But the thing that's unique about one of the things is that the term research in the loop, because it's not just a research paper we study something, we look at some really good outcomes, and we use that knowledge going forward. But for motion, we've been able to take in near real time insights from motion and apply it to enhancing and optimizing the strategies that we're using on I-24. So that's unique, I think, in the research, kind of the workflow that we would typically see. But it also speaks to how we can maybe look at doing that, with our other partners. TDOT partners with, every university in the state of Tennessee and elsewhere. So this is, I think, a good model for that going forward.
Robbie, I'd like to maybe just expand on that a little bit, and then
please, yeah, absolutely,
a couple more concrete examples. So, we turned on the I-24 motion system in November, and the first sort of pictures of traffic data that it produced, I found just completely surprising. They didn't look like most pictures of traffic data I had seen before, and because we were seeing not sort of averaged pictures, you can think of like low res, blurry photographs versus high res. 4K TV or something, you get that increased resolution and you see more. So we looked at these pictures on I-24 motion, and we could see these human generated traffic jams, these phantom traffic jams that were occurring every single morning. When everybody hits the road 6:45 or 5:45 in the morning, something happens, and then these big jams form and they travel backwards on the freeway. And what was amazing is just thinking about like the setup, right? 200,000 people a day go travel on that corridor. No one has a plan to make a phantom traffic jam. And yet every morning it happens, and these waves travel at 12 miles an hour against the direction of travel. Right? Once we were able to see day in and day out that these waves form on the freeway and move backwards at a really predictable rate, we were able to engineer the variable speed limit control system in a slightly different way to help keep in front of that growing pocket of congestion. So drivers that travel down the freeway will see speeds that tell you 70 and then 60 and then 50 and 40 and 30. What they're doing is guiding you into the back of stop traffic. And we know how fast that stop traffic is moving backwards on the freeway. So we know how to move those messages that motorists see. That's one concrete example where something straight out of the motion MRI kind of helped us understand something that was happening operationally, that we were able to make small changes to the way the variable speed limit control system works today. You also flagged, hey, I mean, part of this is about collaboration and community building and working with industry partners. We were very fortunate to be opening motion at the start of a test called Circles. And Circles was a partnership with 5 universities, University of California, Berkeley, Temple, Rutgers, Vanderbilt University, the University of Arizona, and 3 automotive partners. Nissan North America is just down the street on I24. They donated 97 vehicles for us to run an experiment. Toyota contributed 2 vehicles and General Motors contributed a vehicle. It's a fleet of 100 vehicles. And then folks from our community volunteered to go drive those vehicles, but not before we removed the stock cruise control system on that car and replaced it with a research grade cruise control. And that research grade cruise control basically helped kind of do what the variable speed limit system does right now. When you see the slower speeds, you can glide into the back of a traffic jam instead of racing and smashing into the back of other vehicles. We do the same thing with the cruise control. If we can tell drivers, the automation system on the car, that traffic is slow ahead, then maybe we can slow those cars gracefully into the back of the traffic jam instead of suddenly. And so we fielded 100 vehicles all in morning rush hour traffic. Obviously, from the science point of view, we're trying to understand how much energy we can save drivers by smoothing out these sudden speed up and slow down patterns. But the automotive manufacturers are also interested in how they can make the next generation of adaptive cruise control equipped vehicles that might be on vehicles in the not too distant future. The Department of Energy, the National Science Foundation, they're interested in understanding questions like how much energy is consumed by the congestion that we see on the roadways and how much better could it be? Similarly, how many crashes that we see on I-24 are caused by these phantom traffic jams? Mm-hmm. The conventional wisdom is that the crashes cause the jams, and motion is starting to help us unfold that, in fact, it's the phantom jams that cause the crashes that cause the bottleneck-based congestion that we all are all too familiar with. So get rid of the phantom jams, you can get rid of the crashes, you save on energy, you save on safety, you save on efficiency, everybody has a smoother commute. That's what we're really trying to target. And the collaborations with automotive partners, the departments of transportation, the research labs in industry, the research labs in universities are all playing a vital role to help advance that future.
That's great. Thank you for that, Dan. And, it sounds like it's a good win for a lot of different partners and obviously for the motoring public. Matt, I'll throw this one your way. And again, Lee, Dan, feel free to jump in at any point. But, with you all's role in all of this, what were some things, Dan mentioned sort of the phantom jams. Is there anything different or in addition to that, you all have been involved with that you may have seen now happening that you may not have realized before? Or was it all, we really just don't know, that's why we have to do this project, that's why we need the data? Were there any sort of unexpected outcomes, thus far from the project?
Sure thing, Robbie. One of the things that was so impressive when the Circles experiment happened was the amount of work and effort that went into that by the research team. We had over 60 researchers on site, and that was the larger Circles team. And that group is a network that has since been sharing the news about what was achieved and what was accomplished. And we've already got some surprise outreach from from startup companies all over the world saying, we think we can use your data to help us better understand whether our product is going to be something that's useful for the transportation community. And so some of those have been real surprises. And it's been through this community, this research community that initiated with Circles is a big part of it. Also, TDOT did just an incredible job of communicating the launch of the Motion project to the public. And we have some estimates that we reached an audience of over 1 billion reads when all of the data went out through the national networks about here's what's happening. And so that has cultivated interest from unexpected sources as well. And this is one of the surprises, but also the desired outcomes, because when you create something new, the question becomes, will it get used? How well will this get used beyond the initial experiment? And what we have been seeing so far is tremendous interest because they see the value in the data. The data really is the absolute most important currency for this type of research and this type of refinement of whether it's on the private side with product development or on the public side with better understanding how can we make better smart corridors, smarter smart corridors, so to speak. And so because of the quality, the quantity, and the insights that can be derived from the data, which is really a credit to the Vanderbilt team and their ability to take a tremendous amount of information that's on its own would just be overwhelming and convert it into something that allows us to derive new insights into how traffic is behaving, how individual vehicles are behaving around one another. All of a sudden, that has opened the doors for lots of possibilities of what's new and what's next. And so one of the things that we're very fortunate to be able to do is help support TDOT and Vanderbilt with those conversations around what's new, what's next, how can others benefit from what has been built here that ultimately results in a benefit back to Tennessee. And that could be a benefit relative to traffic, to safety, and the products that are incorporated into the vehicles that we drive, or that it may be something that helps enhances the safety of our emergency responders. But it also can come to us in other forms as well, which is interest in Tennessee, economic development interest in Tennessee, seeing what we have here, which is unique, and being able to say, look, can we potentially partner with you in a way that helps us both collectively manage the infrastructure so it's safer and more reliable for everyone. And that's been one of the fantastic surprises along this journey that we're looking forward to seeing how this plays out with continued interest coming from the community in so many different places, both public and private.
Awesome. Thank you for that, Matt. Dan, Lee, anything to add to those comments there?
I would just say, Matt described it as a surprise, but kind of an expected surprise. The level of response is a surprise, but we, in the planning stages and kind of from the conception of this going through, we hoped and then kind of expected that there would be, because of the uniqueness and because of our view or our vision of what it could be used for, in the different use cases that we would expect to see what we've been seeing. We're the team of Vandy and TDOT and Gresham, have been very strategic about getting the word out, but also being prepared to facilitate experiments and to help different entities, different types of entities in different ways. So it could be the data feed, it could be facilitating an experiment, and we've done the work around how we would do that and how, because it's one of the unique aspects of this test bed is it's an open road. I mean, most of the test beds in the country, and there's a different types out there, but a lot of them are closed track. And they have value, it's not, but this one is among different things, among many things, is unique in that way. So they're I guess just to add to that, it's an expected surprise, if that's a thing.
Yeah, no, that's great, and I appreciate you calling that out, particularly with test beds. It may be on private tracks, private facilities, part of research institutions, having this as a live open road, helps really, you're not making as many simulations, I wouldn't think, because you're actually getting that data. And I think that's what makes this such a unique feature. It's not being done in a vacuum. It's being done with, how we live and work and commute and travel. So very cool. Dan, you talked a little bit about the Circles Consortium and the research institutions. And, Matt, you talked a little bit about the interest from, private companies, manufacturing technology companies, things like that. Lee, I'm going to put you on the spot again, and I'm sorry, buddy, but I really, like the perspective of the Tennessee DOT. So I would imagine in industry circles and, when you're talking to friends in Florida or across the country, there's probably a lot of interest around what's happening here. Maybe if you could just, what are the conversations that are we having, either within the state of Tennessee, or, elsewhere, or, I would imagine there's a lot of interest and a lot of kind of staying close to what's happening here and monitoring all that and, maybe looking for opportunities to replicate this in other places. So let's maybe start within Tennessee. What are the conversations that are happening, particularly with municipalities and regional governments across the state?
Well, I think that we're definitely interested in those conversations, have had some and have having more. And I think that there's two aspects to it. One is just to learn from the experiments that we either have done or have planned. And then also to invite others to come and, and to perform their own experiments. In the state, the example that comes to mind that most all states would have interest in, than anybody who operates a freeway, is the move over law, as an example. And it's one of the things that we'd like to pursue. Is one of the experiments is to, how is the compliance with that? That goes again to safety of our responders. Mm-hmm. And how can we improve that? How are drivers responding to it? Is there something we can do to maybe make that compliance improved and that sort of thing? And other states have expressed interest in that. So that is one example. And then the other one, it's a lesser, or it's a smaller group, but states that have active traffic management, the lane control system, the variable speed limits, are very interested in, how are we able to optimize and improve those strategies with motion, because typical deployments have, kind of the textbook answer as far as how you set up your variable speed limits and how you operate them. Well, we're able to take that to the next level. And so other states are definitely interested in, a lot of it has to, we're trying to facilitate those conversations through our different organizations like AASHTO, right. Pooled fund studies and that sort of thing. So that's a growing area for the outreach for this testbed, for sure.
Excellent. And with the application of something like this, we know it's being done on I24, in a metropolitan area. Is there opportunity and value in looking at rural safety, particularly along our interstates? I think about the move over law, I think about traffic incident management, that type of stuff, in some of those areas, maybe with less congestion, but certainly with their own set of challenges from a safety perspective. Has there been any conversation or any thoughts around, how that could apply in a situation, in a more rural area? Let's just say in Tennessee.
Well, I think that, and Dan maybe could be able to speak to this as far as on the academic side, but I think that, there are some insights that we gain from the urban interstate that we can certainly apply, I think, to the rural interstate. There are definitely needs there along those lines. The motion test bed itself is hard to move around.
Yeah, right.
But certainly I think that there's applications and ways to extrapolate, I guess maybe is the way to say it. Gotcha. To different use cases. So I think in one way, again, Dan may be able to help me here. In one way, the fact that we were able to see into traffic flow with this kind of fidelity opens up other options and thoughts about how we could do that in different locations and different settings.
Yeah,
Hey,
Robbie, I'd like to
yeah.
chime in on that.
Please.
There's a very concrete example of how that's already happening from I24 motion. So across the state, Tennessee DOT has a variety of traffic sensing technologies that have been deployed statewide, including on rural parts of the network. And figuring out how to optimize those sensors so they capture all the right traffic data and none of the noise is an ongoing challenge everywhere. With motion, we've been able to look at how those sensors perform in the same I-24 stretch, because we get the full picture with the motion test bed. We're able to dial those things in. Once they're dialed in, then we can take those same findings and apply them statewide. And that makes sensors everywhere else in the state also work better. And it's again, these things that are not, transformational changes, but knowing the right thing to change so that you get the better performance is really the hard thing to do. And motion really has just unlocked the potential to answer these what, why, how questions so that we can scale them statewide.
Thanks for that. There's a question in the chat, and I'll just kind of sprinkle these in as they flow in. But yeah, Dan, while we've got you on the mic, so to speak, you brought up a term earlier in our conversation around phantom jams. Could you maybe just explain that a little bit more? To what is that, and what are you all seeing as the cause to that? Maybe just dive into that in a little bit more detail.
Yeah, a phantom traffic jam is a traffic jam without an obvious cause.
Okay.
All right, so it's not the traffic jam caused by the merge. It's not the traffic jam caused by the crash. I'm stuck and I don't know why. The traffic engineering crowd has obviously it's a really provocative question. I'm stuck in a jam and I can't pinpoint why. So what happened? And folks have really tried both to build mathematical models to figure this out, as well as run experiments. And it turns out the jams happen something like the following. You're driving down the roadway and somebody cuts in front of you, right? And they're driving just a little bit slower than you are. So you tap on the brakes to slow down, to not avoid, crashing into them. Unfortunately, I got Lee right behind me. And while I've slowed down a little bit, Lee takes some time to recognize that my taillights are on bright red and that he also needs to slow down. By the time he makes that decision, he's got to slow down more than me in order to avoid crashing into the back of me. And then there's poor Matt driving down the freeway behind Lee, and he sees Lee's taillights go on. He's playing the same game, which is like, okay, brake lights are on. I need to get off the gas. I need to get on the brake. I start slowing down. But because traffic is just dense enough, he's got to slow down more than Lee did, and Lee had to slow down more than I did. This pattern continues until somebody comes to a complete stop on the freeway. And then that pocket of congestion just travels down the roadway. Every other driver plays that same game. They slow down to a complete stop and then they speed up. They slow down to a complete stop, speed up. It was like super famously demonstrated in a video that some researchers in Japan did. They put 22 drivers in a circular track and said, follow the car in front of you. No merges, no bottlenecks, no multiple lane changes. And out of nowhere, these cars come to a complete stop on one part of the track and race around to the other side of the track only to get stuck in this jam again. So we've known that it's been theoretically possible. There were researchers in the 70s who flew helicopters over freeways in Ohio and caught one of these phantom jams forming and were able to track it. There's a couple different video cameras that have captured a phantom jam on a roadway in Georgia or another one in Europe and blah, 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 blah. But we really have had only anecdotal information about how common these things are. Are they happening all the time and on every roadway? Or are they, like once in a blue moon? Because I can point to one that happened in the 70s. What's happened since then? And I24 Motion has been able to show that these jams are not just like a rare event, but they are a part of every morning commute. We see on the order of 30 of these things form in just the morning rush. So if we can get rid of those jams, I think we're going to have a huge potential to improve safety, improve efficiency, and just improve driver comfort. I don't know anybody that likes slamming on the brakes from 70 miles an hour to zero. So I think there's a huge amount of potential to improve that. We're just scratching the surface for finding out the ways that we might be able to eliminate these jams.
Great. Thanks for that explanation. Matt, does any of this technology lend itself to traffic enforcement? You know, thinking about aggressive driving, racing, distracted driving, those type of things. You know, what are your thoughts there?
So first of all, very important to point out that the infrastructure that was put in place for I-24 motion is not used specifically for enforcement actions relative to an individual person. There's no personal information that is collected as a result of the test bed and its infrastructure, and that is by design. However, it has revealed that some of the origin stories of these phantom traffic waves that Dan has just described, we believe there's a strong correlation between aggressive driving behavior. And let's just generally categorize it as that. Whereas if there is a gap in the stream, and all of a sudden, okay, well, I'm going to more than close that gap by going beyond, you know, the speeds that are posted on the variable speed limits, because it appears it's open in front of me, not realizing that I am just moving myself into the back of the next wave and propagating yet another phantom traffic wave. And so for us, it's more about a way of education and also insights into understanding how driver behavior, how the choices that we make as drivers impacts not just us, but all those around us as well. And so if we can help get the message out beyond just the typical public information campaigns, but actually take it to the level of the data is telling us this is happening. If we can start to encourage a different level of response with that driver behavior, then that can have an impact on choices. And so the choices to, you know, to be an aggressive driver, to whether it's to exceed the speed limit or to just not understand how the advisory message that are given are to your benefit. And so we see that as a way to kind of close that loop by actually saying, well, this is actually quantitatively what happens. Use that as a public information tool. So we're playing with that idea to see if that's something that kind of elevate how we communicate these impacts with the public and change driver behavior. Because at the end of the day, you need the driver's participation in order to get the most out of these systems. And so bringing more awareness of some of these types of behaviors that negatively influence the traffic stream is one of the ways that we see as the potential to enhance our messaging around how we can advise the public about public safety issues through data that is taken and communicated in a very clear and concise way. You know, these are the impacts and these are some of the results, you know, in addition to just the impacts to your personal safety, as well as those that are around you. So that's one of the ideas, Robbie, that we're considering for that specific issue.
Excellent. Thank you for that. I'll keep it with you, Matt, but I'd really like to kind of get the whole panel's perspective because you all, you know, represent different groups. Avoid saying kind of what's next, but you know, what other opportunities, you know, do you all see at this time? Again, knowing that this is still, you know, perhaps in its infancy, you know, we're still learning a lot, still getting a lot of data, but you know, what do you all see as, you know, future opportunities, you know, as a result of the good work being done?
Yeah, Robbie, I can kick that off. And
yeah, please.
I put it in two categories. One are the types of things that we see that could be of direct benefit to TDOT and how they're operating their system and infrastructure. Okay, and those are the next advances, and some of these things have already been touched on, such as the move over laws,
right,
in understanding compliance. But it's really the smart corridor is still relatively a new thing. within Tennessee. It's new to Tennessee drivers. Is the more we understand how drivers are reacting to this new information, to this new infrastructure, the better we'll be able to optimize how that infrastructure works. And so those are some of the early wins that we see in the what's next category. Is there a way to better understand how that information could be used within our own operational procedures and protocols to make it more effective? And so we've already started down that path, but as we continue to roll out new features of the smart corridor as well, is using this research in the loop feedback tool in order to kind of optimize things. So that's one category. Another category I would put in this, it would be the interactions with industry at large. And so I would put these in several categories. One is USDOT. USDOT has a very robust research program, and their research program informs a lot of the policies and protocols that go into regulatory decisions about, first of all, just what's in a vehicle. What is in a truck? It's in a commercial vehicle. And so those conversations have started to reveal that perhaps Motion could do something to enhance their research program that affects how all vehicles are made, or how all vehicle features that are regulated through, whether it's through the National Highway Traffic Safety Administration or the Federal Motor Carrier Administration, as how can we get better data that will help them with some of these regulatory types of decisions and rulemaking that influences all manufacturers of that equipment. And so that is one path. Another path is directly with the technology and industry community. And this is really exciting. And this is something I'm super passionate about, because in the past, it's been, the folks who make vehicles, they live in their own world. The folks who operate and build infrastructure, they're in their own world. Well, these two worlds are rapidly coming together because we interact and we have the ability to exchange data with one another. And this is only increasing. And so the more that these two worlds can understand their use cases and how they could complement each other's objectives, the better macro benefit we could provide to the entire community. And so there are conversations underway about how a potential manufacturer, so to speak, could understand how the data that Motion provides could enhance what they have. One of the issues they have is, while they have tremendous sensing capability on their own vehicles, it's limited to what's around their vehicle. To be able to put that in the context of everything else, it's the missing piece for them. And that could be the nugget that uncovers why a driver may disengage a system that's designed to be a driver assist and not get the benefit of that system. They could learn something important there. As on the infrastructure owner side, we get the benefit of when those systems are used and optimized for safety decisions, then it actually helps us with the overall goal of safety and mobility. So this is a potential win-win. And when you bring those two communities together in a tighter and tighter way, then we're able to benefit from the knowledge sharing that happens. And so there's a whole suite of things that are happening right now down that path as well that I'm super excited about.
That's awesome. And I'm just excited to hear your excitement about it. And yeah, I certainly know that this is something passionate for you as well as others. So maybe Dan, let's get your perspective on this, and then we'll ask Lee to share some of his thoughts.
Yeah, for me, it's pretty straightforward. When I can get on a freeway and drive to where I want to be and have zero risk of being involved in a crash, I'll rest. We've made an improvement in safety. We have a long way to go. Part of it is going to be improving the technologies on the cars so that they are harder to crash. Better safety systems, better emergency brake systems, et cetera, et cetera, et cetera. But that doesn't help my 2003 car. So I also want to make sure that the environment in which we drive is safer. And I think an easy, low-hanging fruit is recognizing how these traffic jams are creating crashes. If we can lower the risk threshold by smoothing out the commutes, that's a win for everybody. Then I want to go right back to the very beginning, because Lee charted this vision of how we're moving all this technology into the infrastructure to squeeze as much performance out of the infrastructure as we can. And I totally resonate with that. The lowest cost infrastructure we've already got is the roads TDOT has already built. how bad is it to have a lane blocked for an hour due to a crash in rush hour traffic? When you can't buy that kind of capacity back, like that's instantaneous. It could happen tomorrow if we could stop causing crashes that block lanes of traffic. So let's get the technologies out there. Let's keep the lanes open. It has the direct benefit of everybody gets home at night. It has the indirect benefit of getting us the capacity that we've already paid for.
Love it. Lee?
I'm not sure I can add to what Matt and Dan said. They both were very articulate. I'll just add one thing, just kind of play on what we talked about before, as far as not being able to widen our roads, and being able to manage the freeway, manage our arterials in a more effective way. Motion helps us, gives us insights on how to do that better. That's the thing we can affect. We just don't have the resources or the ground to widen our roads. So this is what we can do. This, and motion helps us do it better.
Great, thank you so much. Let's open it up to some more audience Q&A. We've had a few more come in here, and folks, please, enter the chat with some questions. We'd love to hear from you all. I'll start off with this one. We talked a little bit earlier about the data being collected, my words, a little bit anonymously. It's not identifying a particular person, their license plate, that type of thing. But are there any considerations, particularly when we think about HOV and dedicated bus lanes and things like that, as part of this research? Have there been any conversations around that, or thoughts around future applications? Maybe what does that look like? And I'll just open that up to whoever wants to take first stab, but please, the rest of the panelists jump in.
Well, I'll give the short answer. No, we haven't currently considered any research questions related to bus lanes, HOV usage. Part of it, again, as Matt highlighted, is by design.
Yeah.
Motion is not set up to identify whether or not there's one or more people in a car. It's not technically possible. It is thematically aligned with understanding how to use the infrastructure as best we can. It's absolutely aligned with trying to understand questions like what are the consequences of operational strategies on the freeway. I think that at least on the research side, we are interested in moving people as fast as possible, as safely as possible. And carpooling and buses are very effective technologies for getting a large number of people through a very small amount of space. Kind of the rule of thumb we use is, on the technology side, I can do all the fancy tricks in the world to try to digitally glue two cars together to drive very quickly with a small separation. It's a technology called vehicle platooning. That's a lot of work when I can get the same benefit by just picking up somebody else and having them drive in the car with me. So I think we should and will continue to explore all mechanisms to improve the number of people who can get access to jobs, schools, healthcare, et cetera, et cetera, et cetera. And that includes what we can do in transit and high occupancy vehicles.
Great, thanks. Matt, Lee, any other thoughts around that?
I'll just say one quick thing on the bus lane, the dedicated bus lane. One of the strategies we have kind of in our overall concept of operations is what's called hard shoulder running, or bus on shoulder, where we utilize the shoulder on a limited basis for that. And we haven't explored this research question, but I believe there'd be some benefit to looking at that strategy with motion. One of the things that is makes it difficult to use that strategy is the width of our existing bridges. But I think there is some benefit to looking at using that strategy, bus on shoulder, between those bridges, and how we could, how that could look, how that could operate. So that's the type of thing, as far as it goes to the different strategies on I-24 that we want to deploy, and how motion can help us understand those better before we deploy those, and then when we do, to optimize them. So that's just one application, I think.
Great, thanks, Lee. Any thoughts from your end, Matt?
Just one quick, I put this in a related category,
Okay.
which is, TDOT announced this year the support for the Transportation Modernization Act has resulted in this initiative around what's being called choice lanes as one of the future mobility solutions in that'll be coming to Tennessee. And part of choice lanes is new dedicated infrastructure in the urban areas. And one of the things that I frequently see with those types of arrangements is typically those are great opportunities for express bus service, or to have transit favorable conditions where, in some cases, those buses use those lanes without a fee. It all depends upon how the operational rules are set up for the choice lanes. But these are important things to consider as I'll put it in the context of there's other new infrastructure that's being planned for Tennessee. If motion can be used to help us understand better ways to deploy the choice lanes of the future in Tennessee, then that's also going to be a win-win for the state.
Thank you for that. Had another question come up in the chat. What is the projected time frame for enough cars on the road with the necessary interactive technologies that will make the system more effective?
I'll take that one today. all I need you to do is follow the variable speed limit control system, and the car you are currently driving on I-24 already has the capability to make this system much more effective. In terms of the actual technologies that are appearing on vehicles, the types of technologies that will do this for you automatically are smart types of cruise control called adaptive cruise control. Those technologies are already on the market. The type of timeline to get the enhancements in, it's usually on the order of something like 2 years from idea is ready for prime time, and then it goes into the engineering cycle and shows up on a vehicle. There are some manufacturers that do it faster than others, but it doesn't have to take too long. And the types of vehicles that are on the market right now, the majority of the best-selling cars in America have these types of automation systems as either a standard or optional feature. So it's not an infinite distant future far, far away. These are things that are like really starting to roll out to dealerships right now.
And I would imagine with the more, that you see that in automobiles, you get more comfortable with that. That's only just going to make people more comfortable. It's going to allow for hopefully better outputs there. So as all these new technologies are being brought to market, from an automotive perspective, and people get more comfortable, hopefully that, allows us to have, A, better data, but B, safer roadways. So.
Hey, Robbie, I wanted to mention one thing about what
Sure.
Dan said. The not necessarily technology, but the compliance rate. I think the studies have shown, and Dan, correct me if I'm wrong, I want to say it's like 5, maybe 10% of the cars in the traffic flow complying with something like variable speed limits can effectively smooth traffic. So it's not a time frame as the questioner had, but it definitely is something that can, like Dan said at the very beginning, it can happen now with more compliance.
Great, thank you. Matt, anything on that particular question?
No, I think the other panelists covered it very well.
Great, thanks. Let's see if we can maybe gin up a couple more questions from the audience. This one came in. I have the adaptive cruise control. It seems to slow traffic down when I use it. How does that affect, what we're thinking, phantom traffic jams, things like that?
Yeah, there are many types and flavors of adaptive cruise. Maybe just to level set, I mean, the generic cruise control is the one where you set it at 70 miles an hour and it runs at 70 until you run into something, right? You cancel it when there's a car in front of you, or you press the plus minus buttons to adjust the speed a little bit. The adaptive cruise is a little bit smarter. It's got a forward-facing sensor, typically a radar sensor, that measures the distance and speed of the car in front of you. And if it's going slower than you are, it slows you down. And usually they try to follow a rule that many of us learned in driver's education: follow the car in front of you, by leaving a 2-second gap or a 3-second gap. Basically, these smart cruise controls are doing the same kind of thing. How well they implement that, and also how far of a gap they take, will basically will shape how it influences the traffic flow. One of the things that we've been working on really for the last 5 years, as well as many researchers around the country, is really to help close the gap between what's happening on the vehicle and what's happening to traffic overall. And it doesn't take a huge amount of reasoning to think through this, right? That if the cars are following with larger separations than what you or I would typically do, and that's going to somehow eat up capacity on the roadway, all else being the same. And on the other hand, if we can design them to follow, behave like us, keep a close separation most of the time, but leave a larger gap when the person in front of you is about to race up and slow down at a traffic jam, you can maintain a more constant average speed that improves traffic for everybody else behind. So yeah, I'd have to know more about the specific adaptive cruise to know exactly whether that's one that is known to be potentially more problematic for traffic or more compliant. But that's generally how those systems work. And I would say that every auto manufacturer that we talk to is very interested in making sure that those designs are safe, number one, comfortable, number two, efficient, number three, and increasingly, they're more concerned now about what that's going to do to the traffic overall in ways that they can help shape traffic for the better.
I'll say one thing to add to that, Robbie, is just from a traffic management standpoint, I'm okay with the driver going a little slower. The concept is we all go a little slower, we get there faster, because we try to we eliminate, or we have fewer the intensity of the phantom jams is less. So there's that whole concept of how you pour a Coca-Cola into a glass. If you pour it fast, it overflows. If you pour it slowly, it fills up in a gradual fashion. That same concept applies to traffic. If we all go a little slower, we get there faster. So I just would just that little plug for traffic flow and safety there for from TDOT.
Thanks, Lee. Got another question that popped up. All right, compliance with speed limits is going to be a huge challenge. What are you all thinking as far as solutions from that perspective?
I'll say really quickly, and Dan and Matt could probably do this, add to this, but just say that we've potentially turned on the variable speed limit system in June. We've seen overall, we're still studying this and still collecting data on this. We've seen a fair amount and a pretty good improvement in compliance with the speed limits. One of it is just that it's more often, it's every half mile it's showing you what the speed limit is, and then also the compliance with the variable speed limits. But certainly I'll let the other guys kind of add to this. But the compliance is definitely a challenge, an issue. We've seen some good early returns, but there's a lot more work to do there.
Great, thank you, Lee. Sort of getting toward the end of our time today. First off, just want to thank you, Dan, Lee, Matt, for sharing your insights, your expertise. This has been a great conversation. I always learn a lot coming out of these conversations. You all just bring such a good perspective, and I just love the way that you were able to break down, some pretty complex concepts for myself and for others. So thank you for that. I guess we'll go around the table, so to speak, and just any final parting thoughts for the audience today, or anything else you'd like to make a plug for. Dan, we'll go with you. We'll go in alphabetical order here.
I'll just say that I think the environment for innovation in Tennessee in transportation is really bright.
Awesome. Lee?
I'm excited about the improvements in safety we've already seen. I'm excited about what we have ahead, both in the context of freeway management, but as Matt mentioned before, the Transportation Modernization Act Tennessee DOT is taking some really innovative and effective steps forward in how we deliver projects, and that rolls back to how we manage the roadways. So it's an exciting time in Tennessee for sure.
Absolutely. How about you, Matt?
Robbie, my final takeaway is it's not about the technology, it's about the people. There's a lot of people behind these efforts that make this happen. And then our outcome here is to make an impact for the public. And so technology is a tool to help us do that, but at the end of the day, it's about people.
That's great final thought there. And I'm really excited to see where all this is going to head. I mean, just all of the spinoff opportunities and the more data we're able to collect and how that's really going to affect, safety first in Tennessee is going to be super exciting. So just in wrapping up, again, thank you all for your participation. Great conversation today. Thank you to the audience for showing up, for asking some great questions. And, Cumberland Region Tomorrow is proud to offer this type of programming. There's a lot of different topics. We've got an upcoming event, the Power of 10, which is our annual summit. That's going to be here in a few weeks on November 9th. We're going to be discussing housing affordability in the region, which I think is something that probably resonates like congestion, like safety with a lot of us. And so hope that you all are able to sign up and attend. More details are available on our website. But again, thanks for everybody to be here today. Really enjoyed the conversation, and we hope to see everyone around real soon.
Thank you for attending the Power of 10. We hope you enjoyed today's discussion. Have a great day.